Alrighty, here's part 2. Let's factor x squared minus 35 minus 2x. All right, is there a GCF? Is there one number or variable that divides out of each one of these terms evenly? No. Now, there's one thing I notice. I don't know if you've noticed it. Do you notice what I notice? All right, remember that standard form of a trinomial is ax squared plus bx plus c. They've got our terms out of order, so we've got to fix that before we start this. So this right here, I'm just going to rearrange things. I'm going to say that's x squared minus 2x minus 35. So now what's your a, what's your b, and what's your c? Well, a is 1, b is negative 2, c is negative 35. Okay. Back to the t-chart. A times c goes here and b goes here. What is a times c? Well, that's 1 times negative 35. That's negative 35. What is your b? B is negative 2. So I'm looking for two numbers that when I multiply them together, I get negative 35. That could be 1 times 35. Now when I add those together, actually, no. 1 times 35 is not negative 35. What if it was negative 1 times positive 35? That'd give you negative 35. All right. Well, let's see what happens when we add the two numbers together. What's negative 1 plus 35? That's positive 34, and we're looking for a negative answer. What are we going to do? Yeah, let's try 1 times negative 35. 1 times negative 35 is still negative 35. What's 1 minus 35, or 1 plus a negative 35? That's negative 34. Okay, at least the sign of our answer is correct. All right. Is my negative 35 divisible by 2? Nope, not evenly. What about 3? Is it divisible by 3? Nope, not evenly. Is it divisible by 4? Nope, not evenly. Is it divisible by 5? Yes, it is. 5 times what gives me negative 35? That's negative 7. What's 5 plus negative 7? That gives me negative 2, and that's what we're looking for. Those are the two numbers we're going to use. So our answer should be xx, I'm going to use these two numbers here, plus 5 and minus 7. And folks always ask me, does it matter what order you put them in? No, it doesn't. Last step is to do the check. People who do the check on the test get better test scores than those who don't. All right, I'm going to use FOIL. Multiplying my front two terms together, I get x squared. Outside two terms gives me negative 7x. Inside two terms gives me a positive 5x. My last two terms multiplied together is negative 35. When I add those two together, get negative 2x, that minus 35, and an x squared. Is that where we started? Yes. So that is factored form. Okay. Whew. Advance. Okay, come on. Let's advance. Oh, there we go. To factor x squared minus 15x plus 44, we have to find two integers whose product is what? 44. And whose sum is what? Negative 15. All right. Moving on. You should always check your factoring results by multiplying the factored polynomial to verify that it's equal to the original polynomial. Many times you can detect computational errors or errors in signs of your numbers by checking your results? For sure, this one. Students who check their answer get better exam scores every time. All right, let's try this one. Is there a greatest common factor, one number or variable that divides evenly into each one of those three terms? No. What do you think we ought to do first here? Are you thinking what I'm thinking? Yeah, it's not in standard form. We're going to have to rearrange things so it looks like that. So the x squared term has to come first. So it's x squared, or if you want to call it 1x squared. Then the x term comes next. That's that one. So plus 18x. And then the 81 comes last. That's our constant. C stands for a constant. Let's make that an 81. All right. Now, A equals 1, B equals 18, C equals 81. All right. AC method. What's my A times my C? Yep, that's 81. What's my B? That's 18. I'm looking for two numbers that when I multiply them together, I get 81. 1 times 81 is 81. When I add them together, I get 18. Well, 1 plus 81 is 82. All right. 81, the next number in line is 2. Well, that's not evenly divisible by 2. What about 3? It should be divisible by 3. Let's see, 3 goes into 8 twice. That should be a 7. Yeah, that's 6. Yeah, that's right. All right, 3 times 27 gives me 81. 3 plus 27 gives me 30. That's not what I'm after. All right. Let's see, is it divisible by 4, 5, 6, 7, 8, 9? Let's try 9. Yep. Let's try 9. 9 times 9 gives me 81. And 9 plus 9 is 18. All right, those are the two numbers I want to use. X, and that's a positive 9, and that's a positive 9. So x plus 9 times the quantity x plus 9. Let's check it. Always, 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 always. Let's see, when I multiply my front two terms together, I get x squared. When I multiply my outside two terms, I get a positive 9x. My inside two terms also gives me a positive 9x. My last two terms multiplied together gives me positive 81. Combine like terms and I get x squared plus 18x plus 81. And that checks, doesn't it? It sure does. All right, you can put a box around this answer. You'll likely see the answer being written this way. Do you see how the quantity of x plus 9 is being multiplied by itself 2 times? Oops. So you'll likely see it written that way. But chances are if you put it in this way into my math lab, it'll accept that also. Just read the blue instructions below the answer box. All right, take a look at this one. First thing I notice is everything needs to be rearranged. So let's rearrange. 3m squared minus 24m minus 60. Okay? We have decreasing degrees of the variable. Now, is there a GCF? Yes, there is. Can you tell me what the GCF is? Yeah, our GCF is 3. And don't forget, that will be part of our answer. This term is divisible by 3. That leaves me with m squared. This term's divisible by 3. That leaves me negative 8m. And this term's divisible by 3. That leaves negative 20. Don't forget, 3 is going to be in the answer. It's going to look like this. okay? That GCF is part of the answer. We've just factored it out. Now, the trinomial that's left, will it factor? If it won't factor, then the answer is going to look like this with 3 terms inside the parentheses. So I don't know which form our answer is going to take. And we won't know until we test that trinomial for factorability. All right, what is my A times my C? Well, that's going to be 1 times negative 20, which is negative 20. And what's my B? Yeah, it's negative 8. All right, if I take 1 times 20, when I add those two numbers together, I get a positive 21. I'm looking for a negative number. All right, what if I did negative 1 times positive 20? That multiplies to give me negative 20. When I add those together, I get a positive 19, and I'm looking for a negative number. So let's put the negative over here on the other factor. 1 times negative 20 is still negative 20. When I add those together, now I get a negative answer. Okay? We're on the right track. Okay, so 2 times negative what? Well, that'd be negative 10. And 2 plus negative 10 gives me negative 8. And that's what we're looking for. Those are the two numbers we're going to use. And it is factorable. Since we found the numbers that work, our answer is going to look like this. So it's going to be 3 times something and something. And let's see, our variable is m. So I'm going to put in an m. That's a positive 2 and a negative 10. Now I've got to check. Always do your check. I'm going to multiply the two binomials together with FOIL first. Front 2 terms gives me m squared. Outside 2 terms is negative 10m. Inside 2 terms is positive 2m. Last 2 terms multiplied together, well, phooey, is negative 20. Combining like terms, I get m squared minus 8m minus 20, which looks like that. Now if I multiply everything through by my GCF, use distributive property, you get 3m squared minus, that gives you negative 24m minus 60. And that looks like the original up here. So that is our answer. Yeah.